to start looking at retrieval. So we've gotten information into that long-term storage. How do we get it back? And so retrieval is the process of transferring information from our long-term memory back into our working memory. So things that we are then conscious of. Say we're conducting mental math and you have to remember how the heck bed mass works. So you can pull that information back out of storage. Most of the time when we forget something, those failures of memory are actually failures to retrieve. We tend not to struggle too badly on encoding the information. We do tend to struggle very badly at pulling it back out of storage. So the first thing I want to talk about for retrieval is actually a special case of memory. And these are flashbulb memories. And flashbulb memories are going to be memories for circumstances in which you first learned about very surprising and a very emotionally arousing event. So previous examples are, you can ask people where they were when they first heard about 9/11. Or the generation before that, you'd ask people where they were when they heard the O.J. Simpson trial verdict. And I have been made aware that students coming into university now are actually so young that they might not even remember the day that 9/11 occurred. But maybe in the future, textbooks will be using where were you when the coronavirus first was discovered, or something like that. But these are supposed to be surprising and emotionally arousing events, and people have this feeling that you have a very accurate recall for very minor details, very specific situations of what you were doing at the time of that event. And so back in 1977, researchers started looking at what they thought was a very special type of memory, where we have this very vivid and accurate recall when these flashbulb moments, when these very intense events sort of stamped those memories into our brains. Now, before we get too excited, I want to point out that a more recent study, so after September 11th, a couple of researchers decided that this is going to be a new flashbulb memory. This is going to be a new flashbulb moment for civilization. Let's study the formation of flashbulb memories. And so they did. So right after September 11th, they started talking to people and asking them, what do you remember about the day? And they wanted to recall as many details about where they were and what they were doing as they possibly could. And so on this graph here, we have how much time has passed. And on this graph, we have number of details they can recall. And so we're going to be looking at the solid blue line first, because that's our flashbulb memory. That's talking to people about September 11th. And so at the beginning, they remember quite a few details. They have 11.5 details on average per person, but over time, as we get up to 32 weeks, the number of details that they were recalling that were consistent with their first day of recollecting, the number of details dropped off, so they were less consistent. And interestingly, down at the bottom here, they started showing more and more inconsistent details. They were starting to make errors in the things that they were remembering. And that in and of itself isn't too bad, because what we care about is flashbulb memories in relation to normal memory. So maybe flashbulb memories are just, you have more details to begin with. But as you can see on the graph, if our dotted lines are ordinary memories, what did you do on your birthday this year? One day after, they remembered about the same number of details, and they show the same decline in consistent details and the same rise in inconsistent details as time went on. So what we're taking here is that these flashbulb memories aren't really that special. So a flashbulb memory isn't a special type of memory. It's not using a special memory system. There's nothing unique about it. Flashbulb memories grow less accurate as time goes on, just like normal memories. So the enhanced emotion that comes from those events isn't really guaranteeing better retrieval of that information. So our take home here is that flashbulb memories aren't really anything independent of normal memory. They're just memories of a day that a lot of people can relate to, but they're not actually special in terms of how they're stored or how we retrieve them. So nothing special to report there. Now we're back to cues, which I told you would be coming back. So cues, we now get a proper definition, and cues are stimuli that lead to activation of information stored in your long-term memory. So like I said, kind of a hint that helps activate the part of your brain that will let you recall a particular piece of information. Multiple cues, so having multiple hints, leads to better retrieval. So if you have more things that help you remember something, you're going to remember it better. And part of this is because there's deeper processing. By having those cues, by thinking about things that it rhymes with, or what image does that word go along with, those are all going to be deeper processing. So you had deeper processing when storing that memory, when using that encoding process. And then there's also more cues to help you access or retrieve it better. So kind of a win-win. And for self-generated cues, things that you make yourself, they have personal meaning, and so they're going to mean more to you than, say, a generic cue that's made up by a researcher in a lab. So if you are making your own hints to help remember something, kind of like when you're setting up a website and they want to have those security questions. If you have to use a generated question and it doesn't mean anything to you, they ask you the name of your first pet, but you've never had a pet, that doesn't really help you. But if they let you pick your own question, or if they have something that has meaning for you, you can choose a question that will help you remember the answer nice and easily. So again, more processing and more meaning helps you recall it better. And so as promised, these cues help with something called priming. And so for a priming task, you could be shown a list of words, because we love our lists, and on that list, maybe there's a word, store. You might not be told that you should remember this list. They can just give you a list of, say, a dozen words. And then later on, if they show you a fill in the blank, so they have STO blank. And so if you hadn't seen their list, you might have said stork, or stop, or any number of words that start with STO. But because you just saw a list that had the word store is now active in your mind. And so you would respond and say store instead of any of the other possible actions, because your brain was primed or activated by a cue that made you think store. So you can use that implicit memory and that pre-activated part of your brain to get the answer that is expected, as opposed to anything else that could fill in that blank. And so when we have situations with cued recall, here's another one of those experiments set up. In this case, our conditions are on the left here instead of at the bottom. It's the exact same graph, it's just flipped. And then across here, we have how many words you remember. So an exact flip of what we've seen before. And in this situation, we're going to see how well people remember a list of words when they're using cues or not using cues, and how those cues were generated. So at the bottom here, if the participant didn't get any learning. If they didn't make or help other people create cues, then it's just them remembering. And in this case, they're provided with cues from someone else. So it has no personal meaning to them. It doesn't necessarily help them with remembering. And here they're only remembering about 17% of the words that they were given in that list. Not fantastic. If the person was able to start creating cues, and they were involved in the process of making cues, so they went through that learning, some extra processing on the encoding side, if they were then given not their own cues, but say a partner's cues, they still got the benefit of the extra learning, so they had extra encoding, but their retrieval wasn't really helped by personalized cues, so they did better than the people who didn't learn, but they didn't do the best. And then our top group are people who created cues, got that learning experience, but were also given their own personalized cues, something that had individual meaning for the test. And when they have their own cues, they ended up doing phenomenally, remembering most of the words from the test. And so in this case, we're seeing that the learning part, the encoding, makes a difference, and the cues, whether they're personal or made by someone else, also makes a difference. And so the more things working in your favor, the better your recall will be after the fact. And so on this idea of having things match when you're learning and when you're remembering things and having everything in your favor, we're going to look at sort of a special case of ways of recalling that work ideally for people. And so this is overall grouped into matching conditions, and you'll see why in just a moment. But retrieval, so pulling information out of your long-term storage, can be increased if the conditions at retrieval, so where you are and what you're doing while you're retrieving that information, matches the conditions that existed at encoding. So what this means is if you are studying for a test, you want to study in the same place you're going to be taking the test because you want the environment to match from when you are studying to when you will be retrieving or taking the test. So if you can make everything the same when you're trying to store that information, when you're encoding it for storage, if it's the same when you are then retrieving that information out of storage, it actually facilitates that retrieval. It makes it easier for you to remember those things. And that's why when I have classes, if we were allowed to be on campus, I always try and have the final exam written in the same room that we have lectures, because it facilitates retrieval. Not really an option this semester, but hopefully you'll be able to study in the same room that you will be able to write the test in, and that should facilitate retrieval. And so we're going to talk about 3 ways that you can actually achieve this matching, 3 different types of condition matching, and each will get its own slide, but this should get very repetitive very quickly because it's the same logic each time. So the first is encoding specificity. So the idea for pretty much all of these is that you're going to learn information together with its context. So you're learning the information along with the place that you are learning that information. And so back in the 70s, there was an experiment where people were given lists of words and then asked to recall those lists of words in one of 2 different conditions. So the first of these, people were trained underwater. So they had scuba divers wearing diving gear and masks, and they would sit at the bottom of the pool and be shown lists of words. And that was where they were studying those lists of words. They were then tested either underwater, still in the pool in their diving gear to remember the list, or they were tested on land, where they'd sit on the side of the pool or in a classroom somewhere and be asked to remember as many words from that list as possible. And then, of course, we did the opposite as well, because you want to get everything from both sides, do the science right. People were trained or did their studying on land, and then were tested when they were underwater in their scuba gear or when they were on land. And at the bottom here, this graph is set up so we have our total score for each of these conditions. So if they were tested underwater and had studied underwater, they did really well. And just like we'd expect, if they were tested on land and had studied on land, they also did really well. But these ones in the middle, where they were trained underwater and tested on land, or trained on land and tested in water, these guys didn't do quite as well because their conditions at training and testing didn't match. Their retrieval conditions weren't the same as their encoding conditions, so they have reduced recall in this situation. And so we can look at this in another setup. So we can have people with, they studied in an area that had noise, and then they could be tested in noise or quiet. Or they could study in quiet and be tested then in noise or quiet. And again, we see the exact same pattern where if your study and test conditions match, our orange bars, you do really well. And if they don't match, you do really poorly. And so these are going to give us more ideas that you should have some encoding specificity. You should be learning in the same situation that you're going to be tested in. We can also have something called state-dependent learning. So not just your physical environment, but also your internal state will matter. So learning is associated with a particular state. So if you are buzzed on caffeine while you're studying, you should probably make sure that you have the same caffeine levels in your system when you get tested. This should be testing. So your retrieval should match your encoding state. So if you drink lots of coffee when you study, you should drink lots of coffee when you write the test. There's lots of non-drug examples as well. Your mood matters. So if you're in a good mood when you study, you should be in a good mood on the test. You don't want to be happy for one and sad for another. Levels of tiredness, physical fatigue, all of those things. You want to match as many conditions as you can. And so we see the exact same graph set up here, but this time for our state-dependent learning. So if people are put into a sad mindset and then study, if they are put in a sad mindset again when they're being tested, if they match conditions, they do well. If they are studying when happy and tested when happy, they also do well. But if they study while sad and are tested while happy, or study while happy and are tested while sad, they don't do as well. So again, if the conditions match, you do really well. If they don't match, you tend to do less well. And our last type of condition matching is this transfer appropriate processing. And so this is the same basic idea, but with a little bit of a twist to it. So we're saying that memory performance is better if the type of task at encoding matches the type of task at retrieval. So this isn't so much about your environment or your internal state. This is talking about the type of task that you're doing. So if while you're studying, you're using a meaning task. So maybe you have a bunch of cue cards and you have a definition on one side and the word that it defines on the other. That would be a meaning type task. And then if your retrieval is, does this word rhyme with blank? Well, your meaning task didn't really help you with that. So you might not perform very well because the way that you studied didn't match the way you are retrieving that information. If you are studying with a rhyming task and are tested with a rhyming task, then your performance will be quite a bit better. So again, you want to match your internal conditions, your external conditions, and the type of processing, the type of task that you're using, all of those should be kept as consistent between studying and testing as possible to try and help you remember this information better.